Today we are going to see about the types of learning, and coming to the syllabus of the module 1, we have foundations of learning, that is components of learning and learning modules, geometric modules, probabilistic modules, logic modules, grouping and grading, learning versus design, types of learning, supervised and unsupervised and reinforcement, theory of learning, feasibility of learning, error and noise, and about the training versus and testing, and theory of generalization, generalization bound, approximation generalization, trade-off, bias and variance, and learning curve. All this will be covered in the topics of the module 1. Coming to the machine learning, which is concerned with the right features, which is used to build the right modules which achieves the right task. And this is also used to detect the spam emails, where machine learning is also concerned with the models to achieve the right task. Task is nothing but we are using the binary classification, and features is variables for describing the email, and modules is nothing but connections between the features and the label. So these are the main ingredients we use it in the machine learning. Then coming to the binary classification, it has only two possible values. That is, we will be checking whether it is a spam or not spam. And coming to multi-class classification, here we will be checking whether the label has any number of values, that is cat or dog or rabbit. Then task. Here we have two types of learning called supervised learning and unsupervised learning. Supervised learning, in those supervised learning we have two types, classification and regression. And in unsupervised learning we have clustering and associations. And what are the models we are going to see in this machine learning is geometric models, probabilistic models, logical models, grading versus and grouping models, and also we'll be seeing the features. Then machine learning models. These machine learning models is, as I already told you, it has been described into several models. Coming to the first model, that is geometric model. These models use observations from geometric which separates hyperplanes. That is, we'll be using one plane to separate the data sets. And coming to the probabilistic models, here we'll be using the process to reduce the uncertainty, which means of probabilistic distributions. And coming to logical models, this is very easy to interpret, which has the logical expressions. And also we have some other models called grouping models and grading models. Grouping models will divide the instance space into segments, and also in each segment will be a very simple and it will be a constant model to learn. And coming to grading models, it is a single and global model over the instance space. Let's see some of the broad categories of the models. That is, geometric models, we use algorithms like k nearest neighbors, linear regression, support vector machine, then logistic regression. Coming to probabilistic model, we use naive Bayes, Gaussian process regression, and conditional random field. And in logical models, we use decision tree and random forest. We'll be seeing clearly about in forthcoming PPTs. Coming to the geometric models, this basic linear classifier constructs a decision boundary by halfway intersecting the line between the positive and the negative center of mass. And this straight line separates the positive from the negatives. It is defined by, this is a formula defined by geometric model, that is w dot xi is equal to t. So here we'll be using the hyperplane to divide the data sets. So coming to geometric models, this as you can see here, the straight line separates the positives from the negatives. So which will be a vector perpendicular to the decision boundary and pointing in the direction of the positives, where t is the decision threshold and xi points to a point on the decision boundary. Here x shows nothing but the points in the same direction as w, as you can see it in the diagram, and from which it follows that the formula which also denotes the length of the vector, that is w dot x was equal to wx was equal to t modulo of x. And also the output variable will be expressed as only a linear combination, that is a weighted sum of a set of input variable, which will also be a numeric value. Then geometric models. In this geometric models, see some on example. You can see that it is very easy to assign both tests as a weight of 4 correctly, and it classifies these 4 emails into spam and not spam. In the mathematical notation introduced in background 1, we could describe this classifier. So using this mathematical expression, we are just classifying it as spam or non-spam. And here also we have the example for probabilistic model that Viagra and lottery, whether it is Viagra is one of the word and lottery is one of the word, whether it will be go under the category spam or not spam. And Viagra and lottery are two Boolean features, and Y is nothing but the class variable with values spam and ham. And also in each row we have mostly classes indicated as bold. And in probabilistic model, to classify a new email, we determine whether the words Viagra and lottery occur in it, and look up the corresponding probability that whether it is belongs to the spam or not spam, and predict the spam if probability exceeds 0.5 and ham otherwise. Such a recipe to predict a value of y on the basis of the values of x and the posterior distribution is called the decision tree. Then logical models. So logical models is nothing but the models which involving logical statements easily translated into human understandable rules. Then for example, if Viagra is equal to 1, then the class will be belongs to the spam. So such rules are easily organized in a tree structure called the feature structure. So as you can see it in the diagram, if Viagra is equal to 0, it belongs to the word lottery, and if it is equal to 0, it belongs to the ham. If Viagra is equal to 1, it belongs to spam. And in other words, if Viagra is equal to 0 and lottery is equal to 1, it belongs to spam. Then decision trees. Decision trees are feature trees whose leaves are labeled with classes, and it has usually with the majority class within the leaf. So many variations of learning algorithms to induce a tree from the training data. Decision trees. This decision trees is a structure that includes a root node, branches and leaf nodes. Each internal node denotes a test on an attribute, which branch denotes the outcome of a test, and each node holds a class label. The topmost node in the tree is the root node, as we already know that. And this following the example which is given below is for the concept of buy computer, that indicates whether a customer at a company is likely to buy a computer or not. If age is young and if he is a student, then he will be able to buy the computer, and if age is young and he is not a student, then he will not be able to buy the computer. For example, if his age is middle age, then he will be able to buy the computer, and if he is age is senior, that is credit rating is excellent, he can buy the computer. But even though he is a senior, if this credit rating is fair, he will not be able to buy the computer. Then decision trees. As you can see, one tabular column which is an example for the decision trees. Using these tabular columns, we have to construct the decision tree. So the first 4 columns will be calling it as a predictors, and the last column is nothing but is our target. And we have took the outlook as our root node, and if outlook is sunny and also windy, and if it is windy is false, we will be having the target as playing golf. And if the outlook is sunny and also windy, then we will not be able to play the golf. And in other words, if we have the outlook is overcast, then we can able to play the golf. And also if the outlook is rainy and the humidity is high, we will not be able to play the golf. And if the outlook is rainy but the humidity is normal, we can able to play the golf. So like this, we can use this tabular columns in many more examples of day to construct the decision trees. This is one of the simple example to construct the decision tree. Then taxonomy of machine learning models. First, we'll be having a grading a bit which belongs to logical. If it is S, we will be using naive Bayes. If it is supervised and it is S, if we use the supervised, it will be taken as trees and node rules. And if the logical is S, but the supervised, we are not using the supervised learning, that it comes under association rules. And if grading is a lot and we'll be using a geometric like algorithm, then grouping is not done, then we'll be using the linear classifications. If grading is a lot and if we use a geometric model under supervised learning, we use the support vector mission, and if we do not use the supervised learning, we'll be using the GMM. And in geometric, if we use grouping, we'll be using supervised learning, will be using K.N. algorithm. And also with similar to the grouping, if you are not using the supervised learning, we'll be using the K-means algorithm. So with this, we are completed with the types of learning.